Well, hello one and all, and welcome to our short on class methods and class variables. I have here a class representing food, and I want to transform it to represent food as you might think of it in a video game. If you've played games like Mario or The Legend of Zelda, you might know that you as a character get some number of hearts representing your life force. And as you eat food composed of various ingredients, you might gain back some variable number of hearts. So to start, here I have a food class where I'm setting, in this case, an instance variable called ingredients equal to some list of ingredients I pass as input when I first instantiate this class. So down here in main, why don't I try to do that? I'll type mushroom skewer, and I'll say that this is a new instance of the food class where the ingredients, in this case, are equal to one mushroom and one hearty mushroom, two ingredients I could find in The Legend of Zelda, let's say. I'll go ahead and run python of food.py, and I won't really see anything, but this does help me check to make sure that everything is running okay. Well, we said before that I wanted to make sure that I could represent the number of hearts this food might heal the player. So it might make sense for me to have, in this case, another instance variable, one called hearts, that in this case determines how many hearts this food should heal the player when they eat it. But if I wanted to get more advanced about it, I might say, I want the ingredients to determine the number of hearts that this food should heal the player. If there are more ingredients, maybe those should heal the player more. Or if there are special ingredients, maybe those should heal the player more. So it seems like I need a way to calculate the number of hearts that this should heal the player. Well, I'm kind of talking about a function here. I'm giving as input a list of ingredients and getting as output the number of hearts that this food should heal. But when I think about this function, I don't know if it should belong to any particular instance of my class. In fact, when I think about it, I want that algorithm to be the same across all instances of my food. Of course, depending on the ingredients, the actual number of hearts will change, but the algorithm, the method of calculating how many hearts food should actually heal you in this game doesn't depend on any particular instance. It might just belong to the entire class. Now, this is a great example of a class method. Some functionality I want to belong to the class, not to any one particular instance. So how could I do this? Well, to call a class method, I simply type the name of the class, in this case food, followed by a dot, followed by, in this case, the name of that method. So I'll type calculate hearts as the name of this class method, and I'll pass in as input ingredients, just like this. So now I'm calling this class method called calculate hearts, but of course I haven't defined it yet. I'll go down below and do just that. I'll say let's define ourselves a new function called calculate hearts, and I'll say it takes as input ingredients, just like this, and I'll start defining it in a little bit. Now, this currently looks a bit like an instance method without the self that is implicitly the first argument of all instance methods. So how can we turn this into a class method? Well, there are two things we need to change here. First, we need to decorate this class with this decorator at class method. This is a special keyword, really more technically a decorator, that tells Python this function coming next is in fact a class method. The other thing we have to do is change the implicit first argument. For all instance methods, that argument is self, but for class methods, that argument is, in this case, CLS, something belonging to, in this case, CLS is denoting the class itself. It's kind of shorthand for typing food, if you will. So here I have my class method. It's common across all of my classes here. Common across all my instances, rather. And what I'll do here is I'll start writing this algorithm to calculate the number of hearts this food should heal based on the ingredients inside of it. I'll go ahead and type hearts, and let's say that initially it heals only one heart, just like this. But as I add more ingredients, maybe I'll get more hearts. So I'll iterate, let's say, over the ingredients list for ingredient in ingredients. I'll go ahead and increase heart by 1, and I'll go ahead and return the total number of hearts at the very end. So now, if I go down below and I print something here, I'll say print this skewer heals, and let's go ahead and use an F string to get mushroom skewer dot hearts heals some number of hearts. So let's go ahead and run this now down below, python of food.py. I'll see it heals 3 hearts. Why? Well, in this case, we started with 1 heart. We added in a mushroom, that's 2. Added in a hardy mushroom, that now is 3. So we're now seeing how this method is actually allowing us to set, in this case, this instance variable across our various uses of this class. So what else could we do with this? Well, maybe we could get a little more advanced with our algorithm. We could say something like this. If, let's say, hardy is in this particular ingredient name, why don't we increase hearts even more? Maybe give 2 hearts instead of 1. I'll go ahead and run this down below as well. And now we'll see that it heals 4. Why? Because we began with 1 heart, added in 1 mushroom, that's 1 heart, added in a hardy mushroom, which is 2, and now we're up to 4 as well. So this is a way for us to, again, have this functionality across different classes. But often, a class method is useful if we try to access or change something about the class within it. And in this case, we haven't really done that yet. So let's also introduce this idea of a class variable. Well, notice here how in my method, I'm starting with some base number of hearts and setting it equal to 1. But in fact, if I want this base number of hearts to be something I could change across all instances of my class, well, it might be a good candidate to be a class variable. Similar in spirit to a class method, a class variable is some variable that is shared across all instances, or in this case, in the class itself. I'll go ahead and say hearts, let's say base hearts here equals 1, and this is by convention where and how I can define my own class variables, usually above dunder init, and simply by typing the name of the variable and setting it equal to a value. So now, according to this class variable, base hearts, all of these meals should begin with a base number of hearts that is equal to 1. But how do I access this class variable? Well, I can use now this CLS keyword. I could say CLS dot base hearts, where again, CLS is standing in for, in this case, the class itself, food, for instance. So now if I go ahead and run down below, I'll see the same thing, but now I'm making use of this class variable, way to organize my information and say, look, across all of my instances, across all of the food items I will make, the base number of hearts will be 1. All right, what else could we do with this? One thing we could do, another good candidate for a class method, is to give the user some new way of making an instance of your class. So if I go down below, maybe I want to allow the user to simply find some food. They didn't make it from ingredients, they simply found it elsewhere. So I could do something like this, mushroom skewer equals food, but now if I look at my dunder init method to initialize some new instance of this class, well, I actually have to supply the ingredients. I can't leave that blank. But what I could do is provide the programmer, in this case, another way to make an instance of this class. When I think about that function, because it is making an instance of the class, that seems to be a class method. It is a method that's going to be common across all instances, and it's also one that, in this case, is producing an instance. So it doesn't make sense for an instance to have it. It's actually going to be the output of this function. So let's think about this. What if I made a new class method down below, one called maybe just from nothing, being able to make, in this case, a new food item from no ingredients. Of course, this will take implicitly CLS as the first argument to this class method. And what if I wanted to also say this, hearts as input here? So now, instead of supplying the ingredients and calculating the hearts, a programmer could simply specify the number of hearts they want their food to have and not worry about the ingredients. Well, how could I do this? If I go down below, this function here should return an instance of my class. Well, thankfully, I have access to the CLS keyword, which refers to the class itself. I could say food, a new instance here, is an instance of my food class, but with the keyword CLS, and I'll say ingredients is really just this empty list. At the same time, I will override that instance variable hearts to be whatever the programmer gave as input to from nothing. I will then return this particular instance. So to be clear, what have I done? I've now created in this class method a new instance of my class using the CLS keyword. I've overridden some of the default values that would have been configured otherwise, and I'm now returning that special instance to the programmer. If I go down below, let's try this. I'll try making a new mushroom skewer. This time though, from nothing. But I'll say that hearts is equal to 2. So in this case, I'm again creating a new instance of my class because from nothing returns to me an instance, but I'm now using this class method from nothing and supplying the argument that hearts is going to equal 2. I'll then go ahead and print how many hearts this mushroom skewer heals. And I'll say, look, it only heals 2 because I, again, told it to heal only 2 hearts. So this shows us here a few uses for class methods and for class variables. Class methods are good for functionality. You want to be shared across all instances of your class. They're good for giving a programmer other ways to make instances of your class. And then, if we look at class variables, these are good for actually embedding information about the class itself and accessing that through the name of the class, not tied to any particular instance of your class. This then was our short on class methods and class variables. We'll see you next time.